All right, so we're going to be talking about the physical properties of amides. All right, so the first thing we're going to talk about is the polarity. So the intermolecular forces, these do form weak hydrogen bonds with half between the nitrogen and hydrogen and the electron pairs on the carbonyl oxygen. So this means that the nitrogen does not have its lone electron pairs readily available. What is going to occur is resonance between the oxygen and nitrogen is going to occur. And so what we're going to see is a mix between the two structures occurs. This is going to create a trigonal planar shape around that nitrogen, and it is going to change the properties, which we will see here in a moment coming up. All right, so for our primary amines, you can see that the oxygen will be able to act as a hydrogen bond acceptor, and the hydrogen on the nitrogen will act as a hydrogen bond donator. We also see the same thing on a secondary amide, where again the oxygen is going to act as a hydrogen bond acceptor, and the hydrogen on the nitrogen will act as a hydrogen bond donator. Now, excuse me, when we start to talk about our tertiary amides, what we are looking at here, again, remember that this is undergoing a bit of resonance. So we are going to see a dipole-dipole interaction with the carbonyl, but that this resonance is going to allow for a more consistent dipole region over the amines. And you can see that in the mole view for each of these. There is a very distinct distribution of electrons. All right, so let's talk a little bit about the solubility. So these can accept hydrogen bonds from water due to the loan of electron pairs on the carbonyl. So these are hydrogen bond acceptors. So because of the resonance structure, these amides are no longer going to be basic. Most nitrogen-based compounds are basic. But because of that resonance structure, that's no longer the case. So these are going to be slightly acidic due to that resonance stabilizing the nitrogen. This is going to allow for hydrogens to be removed, which is going to make this charged, right? So if you're removing an H+, that's going to leave you with a negative charge. Anything that has a charge is going to be soluble in water. All right, and lastly, our phase changes. Notice where the amides fall. They fall between the aldehydes and ketones and the amines. And as you have seen all semester, we're going to just continue to add to this as we add more functional groups.